Today, we are looking into set of numbers. But before that, let's define what is a set. A set is a collection of objects specified in such a way that we can say whether any given object is or is not inside the collection. An example of a set, we can say a set of even numbers, that is all the numbers that is divisible by 2. Any number that is not divisible by 2 is not in that set. So, we can also say a set of all the students in a class. We can also say a set of all the states in Nigeria. So all these are sets. But today we are looking into set of numbers. We have many sets of numbers. We have set of natural number. We have set of whole number. We have set of integers. We have set of rational and irrational numbers. We have set of real number, and we have set of complex number. But let's start from the first one. Set of natural number. Natural numbers. This set of natural number is denoted as n. Using capital N to denote it. Now, this set of natural number include from 1 to positive infinity. That is, we can say that natural number is x, such that 0 is less than x and x is less than or equal to positive infinity, where this x comes from whole number. X must be a whole number. So from this range, 0 is not included. It's from 1. So we can break this thing down by saying that natural number is a set of natural number can be 1, 2, 3, and so on. So this is set of natural number. After this natural number, we have the one called whole number. Whole number, a set of whole numbers. Whole numbers is denoted as W. Whole numbers is denoted as W. So we can say that whole number is Y, such that 0 is less than or equal to Y is less than or equal to positive infinity. So this is definition of whole number. So we can give an example of whole number. We can say that whole number is 0, 1, 2, 3, and so on to positive infinity. So this, you can see the difference between natural numbers and whole numbers. In natural number, 0 is not included, but in whole numbers, 0 is included. Another one we have here is called integer. Integers. For integer, we use Z to denote integer. So we can say that integer A such that negative infinity is less than or equals to A. A is less than or equal to positive infinity, where A is an element of whole numbers. A must come from whole numbers. So this integer, you can see now from negative infinity to positive infinity. So integer contains both negative numbers and positive numbers. We can also say that integer is minus 2, comma, minus 1, 0, 1, 2, dot. Now, this shows that the integer starts from negative infinity to positive infinity. So, this is all about integers. The next one is rational numbers. Rational numbers. Now, rational numbers is the set of ratio of two integers, or we can say is a set of fractions. So this rational numbers is noted as Q. So we can say that rational number is a set of fractions such that this A and B comes from integer and B must not be equals to 0. B must not be equals to 0 for this to be an integer. If B is equal to 0, here will not be fraction. Here will be undefined. So, and A and B must come from integer, and we know what is integer is. The next one is irrational numbers. Irrational numbers. This irrational numbers is a complement of rational number. So we denote these irrational numbers with Q complement. An example of irrational numbers, we have an example. Examples are, we have pi, we have root 2, we have exponent, we have cube root 4, we have root 8, and other ones. These irrational numbers, you cannot express them as fraction. You cannot express them as fraction. Yes, some people will say that pi is 22/7 is a fraction. When you convert that 22/7 to decimal, you will not be able to convert it back to fraction. So all these decimal numbers that cannot be expressed as a fraction is under irrational numbers. The next one is real number. Real numbers. Real numbers are set of rational and irrational numbers. So two of them, both rational and irrational number, give rise to real numbers. And we use capital R. We use capital R to denote real number. So we can say that real number is X such that negative infinity is less than X and X less than positive infinity. So this is actually a definition of real numbers. So real numbers contains all these natural number, integers, whole numbers, rational and irrational. All of them are under real numbers. So the next one we have is complex number. Complex numbers. So this complex number, we use this to denote complex number. So we can say that complex number is A plus IB, such that A and B are elements of real numbers, where this I is equal to square root of minus 1. So this is definition of complex numbers. Now, what makes this thing complex is this square root of minus 1, which we know as I, and this is the I. So A plus B, A and B must be from real numbers. So under this complex number, note that all real numbers are complex, but not complex are what? Are real. Not complex numbers are real, but all real numbers are what? Complex numbers. We are going to stop here under complex number. We are going to still treat these complex numbers as a topic, but here we are talking about it under set of numbers. So we can draw a full table of set of numbers starting from complex. Starting from complex numbers. From this complex number, we have real, numbers. Now this real spread into two, into rational and irrational and rational numbers. Now these two we have from there coming out. This is breaking it up. If you break this one down, you can find integer inside this one. You can also find integer inside this one. So we have integer. We have integers. Now from these integers, we have whole numbers. Now from these whole numbers, we have natural numbers. All these are sets of numbers, from complex numbers down to natural numbers. See you next time. Bye bye.